There are more stars in the observable universe than grains of sand on every beach on Earth. 200 billion trillion. That's a 2 followed by 23 zeros. And around those stars, planets. Trillions upon trillions of them. Many of them rocky, warm, wet, just like Earth. Places where, by every reasonable calculation, life should have emerged. So here's the question that haunted physicist Enrico Fermi over lunch one summer day in 1950. A question so simple, so obvious, yet so deeply unsettling that it's kept scientists awake at night for over 70 years. If the universe is so incomprehensibly vast, so unimaginably ancient, and so theoretically hospitable to life, where the hell is everybody? This is Paradox Labs, and welcome to the Fermi Paradox. The year is 1950, Los Alamos, New Mexico. A group of physicists, some of the most brilliant minds of their generation, are walking to lunch. The conversation turns, as it often did in those days, to UFOs. There had been a recent wave of sightings, and a New Yorker cartoon about aliens stealing trash cans had everyone chuckling. But Enrico Fermi wasn't laughing. Fermi was famous for his ability to make quick, remarkably accurate calculations about seemingly impossible questions. How many piano tuners are in Chicago? How far can a crow fly? These became known as Fermi problems. And now his mind was doing the math on something far bigger. The Milky Way alone contains somewhere between 100 and 400 billion stars. It's about 13 billion years old. Even if intelligent civilizations are rare, say 1 in a million stars hosts one at some point, that's still hundreds of thousands of civilizations in our galaxy alone. And here's the thing. The galaxy is only about 100,000 light years across. Even traveling at a fraction of the speed of light, a civilization could colonize the entire galaxy in just a few million years. That sounds like a long time to us, but cosmically, it's nothing. A blink, a heartbeat. So Fermi looked up from his lunch and asked a question that seems almost childlike in its simplicity. Where is everybody? That question, those 3 words, launched one of the most fascinating intellectual puzzles in human history. Before we explore the possible answers, we need to understand a concept that makes this paradox truly terrifying. It's called the Great Filter. Imagine the journey from dead matter to a galaxy-spanning civilization as a series of steps. First, you need a habitable planet. Then simple life has to emerge. That life has to become complex. It has to develop intelligence. That intelligence has to build technology. And that technology has to reach the point where it can spread to other stars. The Great Filter is the idea that somewhere along this path, there's a step that's almost impossible to pass. A wall so high that virtually no civilization ever makes it through. Here's where it gets personal. There are 2 possibilities, and both are profound. Scenario A. The filter is behind us. Maybe the emergence of life is staggeringly rare. Maybe the jump from single-celled to multicellular organisms almost never happens. Maybe developing intelligence is a freak accident that occurred exactly once in our cosmic neighborhood. If this is true, we might be alone not because civilizations are dying out, but because they almost never get started. We're the lucky ones, the survivors, the exception that proves the rule. Scenario B. The filter is ahead of us. This is the terrifying option. Because if civilizations commonly reach our level of development, but the universe is still silent, that means something is killing them off, something we haven't encountered yet. Nuclear war, artificial intelligence, climate collapse, a threat we haven't even imagined. If the filter is ahead of us, our future is a graveyard, and we're walking toward it. This is why finding microbial life on Mars would actually be bad news. Every step of evolution we discover elsewhere is evidence that the early steps aren't the filter, which means the filter is still waiting for us, somewhere ahead, in our future. But maybe we're thinking about this wrong. Maybe the universe isn't empty. Maybe it's full, and we're just not invited to the party. This is the zoo hypothesis. Imagine you're a zookeeper. You've created a perfect habitat for some fascinating creatures. Would you walk in and introduce yourself? Or would you watch from behind one-way glass, studying their natural behavior, careful never to contaminate the experiment? Advanced civilizations might view Earth the same way. We're not being ignored, we're being observed, protected, quarantined. Maybe there are cosmic rules we don't know about. Maybe contact is forbidden until a species reaches a certain threshold. Maybe we're in a nature preserve and the "no feeding the animals" sign applies to entire planets. But there's a darker possibility, one that keeps some researchers up at night. It's called the dark forest theory, and it comes from Chinese science fiction author Liu Cixin. The logic is brutal in its simplicity. Imagine the universe as a dark forest. Every civilization is a hunter, moving silently through the trees. Resources are finite. Trust is impossible across interstellar distances. You can never be sure another civilization is peaceful. And here's the key. Any civilization capable of reaching you is also capable of destroying you. So what do you do when you spot another hunter in the darkness? You shoot first. You have to, because if you don't, they might. Under this theory, the universe is silent for the same reason a forest is quiet when predators are near. Everyone is hiding. Broadcasting your presence is suicide. And us? We've been screaming into the void for over a century, announcing our location to anyone listening. Every TV broadcast, every radar signal, every deliberate attempt to contact extraterrestrial intelligence, it's all expanding outward at the speed of light. A sphere of evidence, announcing to the cosmos, we're here, we're primitive, we're defenseless. Sleep well tonight. But let's step back from the existential dread for a moment. Because maybe, just maybe, we're not seeing anyone because we're not looking right. Think about it this way. Imagine an ant colony trying to detect human civilization. They might notice our footsteps, feel the vibrations of our cars, maybe even sense the heat of our buildings. But could they comprehend the internet? Could they understand language, television, poetry? We're looking for radio signals because that's our technology. But a civilization a million years ahead of us might communicate in ways we can't even conceptualize. Dark matter manipulation, quantum entanglement networks, dimensions we don't have the mathematics to describe. And consider the timescales. Modern humans have existed for about 300,000 years. We've had radio for barely 130. The universe is 13.8 billion years old. The window in which two civilizations are both advanced enough to communicate but primitive enough to use detectable technology might be cosmically tiny. We could be alone not in space, but in time. Some thinkers go even further. Maybe we're not detecting alien civilizations because this isn't base reality. The simulation hypothesis suggests we might be living in a cosmic ancestor simulation, a universe created by some advanced intelligence for purposes we can't understand. The aliens aren't out there because out there doesn't exist in the way we think it does. So which is it? Are we alone in a vast, empty cosmos? Are we being watched by silent guardians? Are we prey in a dark forest? Or are we simply not advanced enough to see what's right in front of us? Here's the thing, we don't know. And that uncertainty is itself profound. The Fermi paradox isn't just an abstract puzzle for physicists. It's a mirror. The answers we're drawn to reveal something about how we see ourselves and our place in the universe. If we're alone, we're cosmically precious, the only eyes through which the universe knows itself. Every human life carries unimaginable weight. If we're being watched, we're part of something larger, a community waiting to welcome us when we're ready. If the dark forest is real, our survival depends on choices we make in the next century, about weapons, about AI, about what we broadcast into the cosmos. And if we simply can't see them yet, then the greatest discoveries in human history are still ahead of us. Enrico Fermi asked his question over lunch in 1950. Since then, we've sent probes to the edge of the solar system, detected thousands of exoplanets, and listened for signals from civilizations we've never met. The silence continues, but every day we look a little harder. We listen a little more carefully. We ask better questions. And that's the Fermi paradox, a question that sounds simple, but opens up into an infinite abyss of possibility and terror and wonder. Whether the answer is out there or in here, whether it's hopeful or horrifying, one thing is certain. We're the first generation of humans with even the slightest chance of finding out. If this kept your brain spinning, hit subscribe. Paradox Labs digs into the questions that don't have easy answers, because sometimes the mystery is the point. I've been your host, James, from Paradox Labs. I'll see you in the next one.